first one we'll work out of 2.2 is this one. So this section is algebra of functions. So they ask us to do that. So from our notation, we learned hopefully what that means. That g minus f of negative 9 means g of negative 9 minus f of negative 9. So I'm just going to come over on the side and say, what is g of negative 9? Well, the function g is 4 times something plus 7, and what we're inputting in place of x in this case is negative 9. So 4 times negative 9 plus 7 is negative 29. So that's g of negative 9. Now we need f of negative 9. So f of negative 9, f is our input squared minus 4. Notice every time I'm putting something in place of the variable, I'm putting a parenthesis around it. If we did not put a parenthesis around the negative 9, if we just wrote this, that would not be squaring negative 9. And our function says to square our input. This only squares the 9, and then it applies the negative symbol. We want to square that whole piece. So negative squared, negative 9 squared, negative 9 times negative 9 is positive 81. Then minus 4, so 81 minus 4, 77. So we replace g of negative 9 with negative 29. Bring down the minus, and then f of negative 9 is 77. Same signs, we add those. Take the sign of the bigger. So that's what we do there. If this would have been an addition sign instead, then we would have had a plus here, and we would have been adding 77. It wouldn't hurt to put parentheses like this. The value for g of negative 9 is this. The value for f of negative 9 is this. And we're subtracting on this one. If this would have been a plus, we would have been doing this number plus this number. If that would have been, if there would not have been a symbol there, if it would have been gf of negative 9, then we would have multiplied those two. We would have done g of negative 9 times f of negative 9. So that would have been negative 29 times 77. And then we just pull a calculator out and say, well, what is negative 29 times 77? Negative 2,233. Negative 2,233. That's what we got. Yep. If there would have been a slash between there, like so, then we'd be doing dividing. G of negative 9 over f of negative 9. So negative 29 over 77. That doesn't reduce. You could get that as a decimal, or we would probably just leave it like that. So just knowing what the notation means. The second one is a little bit trickier because they're asking us to do this calculation. This is called a difference quotient. And when we get to Cal 1, then we're actually going to find out what that whole thing is for, what it's doing. But in our difference quotient, we have a function called f of x. So in place of f of x, we can replace it with that formula. So we need to find out, well, what does this mean? What is f of x plus h? Well, the way functions work is whatever is in the parentheses, that's what we're substituting into our function. So our function is our variable squared plus 8. Well, our input is that whole thing. What's in parentheses, we're replacing x whatever is here goes in place of x. So this is x plus h, so we can change this x to x plus h. So then we square that out. So a long way to square that out would be just to FOIL it. Remember, when we square a binomial, we take the factor times itself. Anything squared means that thing times itself. And then we'll have a plus 8 on the end. So x times x times h times x, well, h times x or x times h are the same thing. H times h. And then bring down our plus 8. So we have an x squared. We have that twice. And we have an h squared, and then we have a plus 8. And that's as far as we can simplify f of x plus h. We replaced our original variable, which was x, with that whole expression. We simplified it. So if our function, if f is this, f of x plus h is all of that. Quick statement. A lot of times when I square a binomial, I'm going to use the shortcut. Notice when we square this, when we multiply it out, we get this first term times itself, so it squared. We get the last term times itself, so we're going to have the second term squared. And then the outer product and the inner product, those are always going to be the same if this is something times itself. So we'll have the product of the first thing times the second thing. We'll have that product twice. So the first term squared, the second term squared, and then their product twice. Okay, so now we know this part. We know this part. We don't have a value for h, so we're just going to leave it as h. So let's fill in our difference quotient. So it's f of x plus h minus f of x over h. So this is f of x plus h minus f of x over h. So this is x squared plus 2xh plus h squared plus h, and this is x squared plus 8. This came from there, and this came from the definition of f. Since there's a negative in front of this parenthesis, that gets distributed and changes both signs, so that makes that a minus x squared and a minus 8. We drop the other parentheses and bring those terms down. And then that simplifies. Those cancel. Those cancel. So that leaves us 2xh plus h squared over h. Now we can reduce that. We could do that a couple of different ways. We could divide h into both terms, or traditionally the way we reduce it is we factor out the common factor on top. Both terms have an h, so pull out an h, pull out an h. If we pull out the h there, that's gone. If we pull out one of those h's, we have one left. So 2x plus h is what we're left with on the inside. Those cancel, leaving us 2x plus h. So that's the value of our difference quotient. Now, right now, we don't really know what that means probably. But in the future, that is going to actually represent something really important. Right now, we just need to know how we compute that, how we simplify this expression when we're given the function of f. So every function is going to have its own difference quotient. If our function was 3x minus 7, there would be a specific difference quotient for it. This generic formula is the same. What changes is what f is. So this operation or this expression is the definition for a difference quotient. But since f can be different formulas, then that's going to affect what goes here and what goes there. All right, so the last problem that we'll work out of 2.2 for homework is this one. Now, if you were to read the book and possibly in the lecture videos for this section, it's going to have you look at the domain for this function and also look at the domain for this function. And then depending on whether we're adding the functions or subtracting them or multiplying or dividing or whatever we're going to do, they would ask us to combine the domain of each of those separate functions by either doing a union or an intersection or things like that. It sometimes gets confusing. Well, which one do we do? Are we unioning it? Are we intersecting it? Which one to do? So it's actually easier to do this part first. Find out what is f plus g. What does that mean? So f plus g of x means f of x plus g of x, which is x minus 6 plus the square root of x plus 5. So that's what f plus g of x is. You don't necessarily have to have the brackets there. I just put them to indicate that this was the function f and that's the function g. So having said that, now if we were to go back and answer this part, what the domain of this is, well, this is f plus g of x. What's the domain of that function? What numbers are we allowed to plug in? So the better question might be, well, what are we not allowed to plug in? So we're only dealing with real numbers right now. There's not a fraction in this function, so we don't have to worry about dividing by 0. But since we have a square root, this expression has to give us a positive answer or 0. If we end up with a square root of a negative, we don't know what that means in terms of real numbers. That's imaginary. So x plus 5 has to be greater than, or it could be equal to 0. As long as that expression is greater than 0, it's okay. We can take the square root of any positive number. Or if that expression equals 0, that's okay also. We can take the square root of 0. So if we do that, if we subtract 5 from both sides, that means x needs to be greater than or equal to negative 5. So that's the domain for that particular function. As an interval, greater than or equal to negative 5 is from negative 5 to infinity. We include negative 5, so bracket. It's greater than, so it's from there to infinity. Then let's do f minus g of x. So that means f of x minus g of x. So that's f of x minus, and there's g of x. If we're looking for the domain here, it's going to be the same as this one. The things that will make this undefined is whatever makes this negative. So we can only use numbers that make this positive or 0. So our domain, again, x has to be greater than or equal to negative 5. Now, we're not asked for this, but let's imagine if it was g minus f. Here's where we have to really be careful. And here's where my original brackets or parentheses would be helpful. Since this is g of x minus f of x, g is square root, and then we would be subtracting f. F is x minus 6. Well, this minus applies to all of f. If we're subtracting that function, then we need to subtract x and subtract negative 6. So that would be minus x minus a negative. We'll make that positive 6. So this is g minus f, and again, the domain of that is negative 5 to infinity. So how about fg, ff? So fg means f times g. So here we really do have to use a parenthesis. I would encourage you to use the parentheses anytime you're plugging into a formula, at least initially, and then if you don't need them, you can drop them. So there's f, and then g is this. We can't really just, I mean, we could distribute that out if we wanted to, but that is fine. The only thing that we can't do is that can't be negative. So again, our domain, negative 5 to infinity. As long as that gives us positive or 0, then we can do this. ff is f times f, which is x minus 6 times x minus 6. We could multiply that out, which that would be x squared minus 12x plus 36. Notice that would be squared, so the first one squared, the second one squared, and then their product. Their product is negative 6x. That would be twice. That's just using that shortcut. So what's the domain here? There are no fractions, so we don't have to worry about dividing by 0. There are no square roots, so we're not going to end up with imaginary numbers. So we can plug in any number for x and we get an answer. So our domain is going to be all real numbers. Any number you plug in for x can be squared. Any number can be multiplied by negative 12, and then you can add and subtract any numbers. So nothing to make that undefined. Then the last two are f over g and g over f. So f over g would be x minus 6 over the square root of x plus 5. We can't really simplify that any, but what about the domain? So a couple of things. If we look at the square root, that has to be positive or 0, or that would be imaginary. So if we only looked at the square root, as we did before, what's underneath has to be greater than or equal to 0. But what about 0? Can it be 0? If this gave us 0, we would have the square root of 0 on bottom, which is 0, and we can't divide by 0. So we're not allowed to use the equal here. If we subtract 5 from both sides and get negative 5, notice negative 5 is not okay. If you plug a negative 5 in, you get 0 underneath there. Square root of 0 is 0. That's undefined. So negative 5 is not included. The greater than part is, but just the number itself isn't. So how do we list that and not include negative 5? Well, that's where a parenthesis comes in. We use a bracket here because negative 5 is part of the domain. It's okay for x to be negative 5 here, because this just makes 0 and is fine to multiply by 0 or subtract from 0 or add with 0. But we can't divide by 0. So it's only numbers that are to the right of -5, not inclusive this time. Now the last part here is g over f. So this means g of x over f of x, which is the square root of x plus 5 over x minus 6. Again, that doesn't really simplify. So what numbers can we use? So first of all, what's a number we can't use? Well, we have a fraction. We know x minus 6 cannot be 0. If we get 0 on bottom, we're undefined. That's not okay. So if we solve for x, add 6 to both sides. So x cannot be 6. But is there anything else that we can't use? Well, we have a square root on top, so we can't use anything that makes that negative. So whatever's under that radical, that has to be greater than or equal to 0. So the only numbers we can use here, we've done this one several times, is x has to be greater than or equal to -5. So the numbers that make the top part okay are all of these numbers. The numbers that make the bottom okay is everything except 6. So how do we describe we can't use 6 and we can only use numbers that are bigger than or equal to -5? Well, what numbers are those? What numbers are bigger than or equal to -5 but not 6? Let's look at a number line real quickly. If -5 is here, greater than -5 is all of this, equal to -5 is that, but 6 is not allowed to be part of it. So if 6 is over here, that one is not included. So it's all of this, it's all of that. It's numbers that are bigger than or equal to -5 so that this is positive or 0. But when we get to the number 6, that's a problem. 6 is okay up here. We can take the square root of 11, but 6 is not okay here. 6 minus 6 is 0. Just real quickly, let's write that out. So that would be g of 6 over f of 6. So g of 6 is square root of 11. F of 6 is 0. That's not okay. That's undefined, which means we're not allowed to use 6. Any other number that's greater than or equal to -5 is okay. So how do we write that as an interval? Well, this is two different sections. So we go from -5 and we approach 6. We just don't quite make it. And then the other side, we're really close to 6, and that goes to infinity. Two different intervals, then we put a union.